Good morning, fourth grade. Today we will be learning about volcanoes and how they form on our Earth. Before we get started, update your table of contents with our volcano vocabulary. We will be adding 4 words to page 25. So today we are going to learn about volcanoes and how volcanoes change the Earth's landforms. Volcanoes help create landforms around the world. Volcanic activity that created the mountains in the west coast of the United States happened many, many years ago. However, in the Hawaiian Islands, they continue to be built with different volcanic action. How does that happen? Today we are going to watch a video that's going to explain to us how volcanoes help create more landforms. This is an example of what the earth looks like on the inside. The outer layer of the earth is called a crust. These two red and orange layers, they are called the mantle. The inner corner is called the core. We are now going to add these vocabularies to our notebook on page 25. The first word is crust. Crust is the Earth's outer layer of solid rock. Planet Earth is made up of rock, and the most outer layer is called crust. Word number 2 is called a mantle. Solid rock material that it is between the core and the crust. Let's add this third vocabulary word to our book. Magma. Magma is melted rock that is below the Earth's surface. And our last word is lava. Lava is the melted rock that erupts onto the Earth's surface, usually from a volcano. So magma and lava are very similar. Magma is on the inside, and when it erupts, it's called lava. In today's lesson, we will learn how does an active volcano change the Earth.
Corporal Feebles, do I have a hot and explosive surprise for you today?
I see it, Captain. Fireworks that come from inside the Earth.
No, Feebles, these are not fireworks. These are
Mean and angry mountains, that's what.
one of Earth's most incredible forces of nature. So tighten your seatbelt, Corporal. It's time for you to learn about volcanoes.
Wow, that volcano is really spitting out smoke and fire and fumes and rocks.
It's not spitting, Feebles, it's erupting. To get the full story, you have to understand some of the forces at work under the surface, inside the Earth.
Inside the Earth, Captain?
Yes. You see, the Earth has different layers: an inner and outer core, a mantle, and a crust. And the core and mantle are extremely hot.
Okay, I'll bite. How hot?
The inner core, the very center of the Earth, can get as hot as 6,100 degrees Celsius or 11,000 degrees Fahrenheit. And the outer core, the layer that surrounds the inner core, is some 5,000 degrees Celsius or 9,000 degrees Fahrenheit.
Ouch, that's hot.
As hot as the surface of the sun, and hot enough to melt the metals that the layers of the core are made of. But the inner core is kept solid because the weight of the entire planet is pressing in on it. The next layer outside the core, the mantle, is also extremely hot. And at the very top of the mantle, the pressure is less than deeper down, and the extremely hot rock here is molten. This liquid rock is called magma, and it's in constant slow motion as it heats up and cools down.
Sounds like a lot of churning under the surface.
It is a lot of churning, and to understand how it happens, you need to know one very important thing. Hot magma is less dense than cooler magma. When magma heats up, it becomes less dense, cooler magma around it. Liquids that are less dense will always rise above liquids that are more dense. This constant heating and cooling process sets the magma into a rising and falling cycle. The outer layer of the Earth is called the crust. It is a thin, hard, cracked layer of rocks. The crust floats on the mantle below. But the magma inside the Earth is under pressure and will escape through any cracks it can find in the Earth's crust. The Earth's crust is actually made of several huge pieces called plates. And since there are cracks between these giant plates, these make perfect places for magma to rise up and sometimes spill out or erupt. As they are moving, sometimes the plates collide. Even though it happens slowly, when the plates collide, one pushes the other one down into the earth. The layer pushed down into the mantle melts into magma, ready to rise up through the cracks in the plate.
So, that's how volcanoes form. When heat and pressure combine to push the magma up through the cracks of the earth, we have an eruption.
Exactly. So you see, whenever the plates are moving, there is an opportunity for volcanic eruption.
Okay, I understand that, but tell me exactly how magma oozes from the volcano.
No, Feebles, what oozes from the volcano is lava. Once magma exits the volcano, it is called lava. Magma is like soda pop, a mixture of liquid and bubbles, of molten rocks and gases. When you open your soda pop bottle, the gas comes out of it, and before long, your soda pop goes flat. The same thing happens with magma. When it reaches the surface of the earth, most of the gases escape from it, leaving the molten rock a little flat. It is now called lava. Lava contains gases too, but it is no longer under pressure as it flows out of the volcano.
Oh, so this molten rock and gas mixture is called magma when it's inside the volcano and called lava once it's outside the volcano.
You got it.
Okay, but how does magma get from the mantle through the crust to become lava anyway?
Good question, Corporal. You're catching on. As magma collects into reservoirs or magma chambers under the crust, tremendous pressure builds up. Remember, this heated magma full of gas bubbles will find any possible way to escape upward. Most of the time, it will find the shortest way out, or straight up through an opening called a central pipe, or vent, and spill out onto the sides of the opening, or crater. Other times, lava simply oozes from cracks or fissures, spilling out slowly. Different kinds of magma contain different chemicals. These chemicals determine how the magma will erupt and what kind of lava it will produce. A magma that's rich in silicon and aluminum is dark and thick, and the lava it produces moves slowly and cools slowly. A magma that's rich in gases can be very explosive and produces lava that is full of poisonous gases. But a magma that contains lots of water, iron, and magnesium is light, and its lava oozes gently along the slopes of the volcano.
Sounds simple enough. The magma's chemical composition determines what the lava looks like and how it flows.
Right, Feebles. Volcanoes distinguish themselves by their various states of activity. We say that they are either active, dormant, or extinct. What do you think we call a volcano that erupts regularly?
Active.
Right. A volcano usually gives signs that it's active. Tremors or small earthquakes rock its sides. Clouds of smoke or gases escape from its crater. Of the 1,000 or so active volcanoes in the world, about 25 erupt each year. Most of today's active volcanoes are located at the edge of the Earth's plates. Do you know what the Ring of Fire is?
Sure, isn't that a new thrill ride?
No, Feebles. Look at this map. See the ridges of the Pacific Plate? That's where you'll find most of the Earth's volcanic activity. The red dots show where there are active volcanoes. Out of the 1,000 or more active volcanoes, 1/3 are located on the Ring of Fire. Sometimes a volcano's activity will stop for a long time. These are called dormant volcanoes. For example, Mount Fuji in Japan last erupted in 1707, but you can still see steam rising from it and lava bubbling in its crater. Mount Fuji is dormant. So is Mount Rainier in Washington, dormant for over 100 years.
And both are located on the Ring of Fire.
Very good, Feebles, you're catching on. When a volcano has not erupted for over 1,000 years, it is considered extinct. Mount Kilimanjaro in Kenya is an extinct volcano, but you can never be sure. Even extinct volcanoes can revive. Mount St. Helens was believed to be extinct, yet it suddenly erupted in 1980, proving that science isn't always an absolute.
I see. You can never tell for sure if a volcano is totally extinct. It would be nice to know, though.
Oh yeah, Feebles, considering that people insist upon living close to volcanoes, whether active, dormant, or extinct.
Isn't it risky, even dangerous to live close to a volcano?
Sure is, and people risk the loss of life and property.
Gee, Captain, isn't there a way to escape a volcanic eruption, like outrunning the lava flow?
When a volcano erupts suddenly, it's not hot lava that is most dangerous. It's the poisonous gas and tremendous heat that are deadly.
Well, if it's so risky, why would people want to live on the slopes of a volcano?
The soil surrounding a volcano is very rich. All this volcanic material is rich in minerals essential to growing crops. The ash itself is a very valuable fertilizer, and as long as the layer of ash remains thinner than 20 centimeters, farmers welcome it. Old lava flows that have eroded into softer soil yield bountiful crops. In Indonesia, farmers grow rice in fertile volcanic soil. In Italy, other farmers tend to their vineyards and citrus groves on the slopes of Mount Etna. Volcanic activity still holds many mysteries. Although the scientists who specialize in volcanoes, called volcanologists, are constantly monitoring volcanoes around the world, no one is able to accurately predict a volcano's behavior. Laser beams can detect a swelling in the crater or on the side of a volcano. Such a swelling is a telltale sign that volcanic activity is building up. Volcanologists can also use something called a tilt meter to detect this swelling. Such a device measures changes in the slope or angle of the ground around a volcano. You see, as a volcano nears eruption, it often swells as magma fills it. This swelling causes the ground around the volcano to rise and tilt. As shown by the tilt meter, changes in this angle from day to day tell how fast the slope is changing. If the rate at which the ground tilts speeds up, it is a good clue that the volcano is becoming more active.
And a good clue that it's time to leave the area.
Yes, that could be true. When it comes to predicting volcanic eruptions, volcanologists can also gather lava samples. By determining the chemical composition of these samples, scientists can estimate the source of the lava and predict its future behavior. Warning signs often precede an eruption. A plume of smoke may escape from the crater. The streams, rivers, and even the soil in the area may warm up a few degrees. The earth may rumble and shake. Rock slides from the crater or avalanches from the volcano's slopes can happen. Scientists measure, monitor, and record all of these changes and make their best estimates as to when and how a volcano will erupt. As you can see, volcanoes remain very unpredictable. For that reason, they remain dangerous.
Okay, I get the point. Is this thing gonna blow again?
You know, Feebles, we had better get going.
Yeah, before lava, gas, ashes, cinders, and other pyroclastic material falls all over us.
What else can you remember? And make it quick.
Well, that magma rises from the mantle through the crust and erupts through craters and fissures. That convection currents inside the earth help push the magma around.
This volcano is about to erupt. What else, Corporal?
That 1/3 of all active craters are located on the Ring of Fire. That many people like to live along the slopes of volcanoes because the land is fertile. But that's not for me. Let's get out of here.
And I was under the impression that you liked a little pyroclastic activity.